All right, so we've talked about sum and difference. We talked about double angles. So what we're going to talk about here is half angles. And so in my old notes, we used it to prove, we used double angles to prove these, but we don't have to. Here they are. All three of the trig functions are here: sine, tangent, and cosine. So notice that sine and cosine almost look very similar, but inside one, we have one minus cosine x here for sine and one plus cosine x here. Good way to remember the sine one is that sine and subtraction both start with s. So that'll be a good way to remember that this one is a subtraction and this one is the addition. Notice that there's plus or minuses here. So depending on what angle you're taking sine and cosine of depends on what sign we're going to put in front of that radical. Same thing happens if you're going to use this tangent formula. If you're going to use this one, you have to decide, is it going to be positive or negative? What's nice about these two, they all give you the same answer, but these two end up doing the sign for you and you don't have to do any extra work. So that's pretty cool. All right, so let's get started. Cosine of 112.5 degrees. Well, what do we have to get 112.5 degrees? Well, that's 225. So we're going to figure out what cosine of 225 divided by 2 is. Well, we're going to use this formula here. Well, I need to figure out what sine it is. Well, 112.5 degrees is in quadrant 2. In quadrant 2, cosine is negative because you're going left, so we have negative x values. So then we're going to do 1 plus cosine of this angle that I figured out was 225, all divided by 2. So 112.5 degrees is not on the unit circle, but 225 is. So that's what we're trying to do here. We're trying to figure out a value of x that ends up being on the unit circle. So then I'm going to plug in my value of cosine of 225, which is going to be negative root 2 over 2, all over 2. Well, I can rewrite this a little bit. Well, I can first do the plus negative root 2 over 2. But then we have a fraction within a radical, so it's all getting crazy. So let's get rid of this fraction within the fraction. And so let's multiply everything by 2. So we end up having 1 minus, and again, instead of having plus negative, or 2 minus actually, root 2 all over 4. Well, then I have this radical within the radical, which really, there is probably a way to get rid of it from inside, but we're not going to worry about that. However, we do have a perfect square of 4 down here that we're going to do negative 2 minus root 2 all over the square root of 4, which is 2. And that's as far as we're going to take it in this class. Again, you can probably figure out steps to go further, but there's no need. That's as far as we go. So, all right, sine of x equals negative 3/5. So they told us that x is somewhere between 180 and 270. I don't know what that negative sign is doing there, so let's just kind of get rid of that. I'll try to make sure it's off of your notes. So, so x is somewhere between 180 and 270. So that means x is going to be in quadrant 3. So let me draw a triangle where we have an angle x in quadrant 3. So they told us sine of x is negative 3/5. So that means the opposite side is negative 3. The hypotenuse is 5. So then my adjacent side is negative 4. Okay, so be careful. I know I pause there for suspense, but it's negative 4 because you're going left and down. Left and down are both negative. So there's our triangle. We can figure out sine, cosine, and tangent of that, but we have to be very careful with our sine. So x is between 180 and 270. We need to figure out where this 1/2 x is. So I need to divide everything in this range by 2 to figure out where half of x is. So since x is between 180 and 270 and just strictly less than, half of x is between 90 and 135. That means since x is in quadrant 3, half of x is actually in quadrant 2. Okay, that's where 90 and 135 is. So we have to make sure that with these three trig functions, we take into consideration that our answers are going to be in quadrant 2. So for sine of something that's in quadrant 2, then it's going to be positive. So we're just going to plug in into our function. So we have the positive, so we don't have to put a sign there. 1 minus cosine of x, well, cosine of x is -4/5 all over 2. Okay, so again, I'm using this identity, 1 minus cosine of x all over 2 inside of the radical. 1 minus cosine x, -4/5, all divided by 2. And then we'll just do some math to simplify it. I'm going to get rid of this fraction by multiplying everything by 5. So we end up getting 5 plus 4, because minus a negative, all over 10, which we end up getting 9/10. And so I'm going to square root the top and square root the bottom. So we get 3 over root 10, or 3 root 10 over 10 would be my final answer. So again, with problems like this, you want to simplify the radical. If it was something like, root x squared plus 4 or something, leave it like that in the denominator. But this is simple for y'all to do. Cosine of 1/2 x, well, again, x is in quadrant 3, but half of x is in quadrant 2, so that means cosine is going to be negative. And then we're doing 1 plus cosine x, which again is -4/5 all over 2. So we have negative square root. So same thing like before, I'm going to multiply everything by 5, and instead of plus and negative, I'm going to do -4 all over 2, all over 10. Sorry. So we end up getting negative root 1 over root 10, which ends up being negative root 10 over 10. So just making sure you simplify your fractions as much as you can. So again, you want to choose your lesser of the 3 evils here. If you were to do this one, I mean, it really doesn't matter because you're still just dealing with a bunch of fractions. So we can try that one. Let's see what sine of x over 1 plus cosine x is. So sine of x is -3/5, and then we have 1 plus the cosine of x, which is -4/5. Well, -3/5 over 1 minus -4/5 is 1/5. So then we end up getting that our final answer, we multiply the top and the bottom by 5, we end up getting -3 as my answer. Does it make sense for that to be negative? Yeah. Quadrant 2, tangent's negative because your y's are positive and your x's are negative. So positive divided by negative is a negative. So again, when you're using these two equations, they come out automatically as positive or negative depending on where the angle is. If you're going to use this one, you have to ask yourself, which sign would it be? All right. Well, what if we wanted to write this into a single function? Well, since it's 1 minus cosine, it's going to be sine because, again, subtraction, sine, both s. My angle is 40, so I need to half that 40. So we end up getting that sine of 20 degrees. So remember that in your worksheet, you have solutions, you have answers at the bottom of the worksheet. So don't just go from here to here. Show some work on how you went to sine of 20. In here, we have 1 plus cosine. So if it's not subtraction, it's going to be cosine. And then we're taking half of 80. So we end up getting cosine of 40 degrees. Now, some of y'all might be asking, why did I stop there? Well, 20 and 40 are not on the unit circle, so it's fine to stay there. Just make sure you're following the steps and ask any questions if you have any of that in class. What about tangent of 22.5? Well, what angle on our unit circle would I have to get 22.5? Well, that would be 45. So you get to choose which formula you want to use. We can do sine over 1 plus cosine x. We can do 1 minus cosine x over sine of x. Either one works. The thing is that if I do sine and cosine of 45 degrees, I'm going to get root 2 over 2. So instead of having 1 plus root 2 over 2 and cause myself more work, I'm going to use this formula. I'm going to do 1 minus cosine of 45 degrees over sine of 45. Again, it's just choosing your lesser of the evils here. Which one do you want to do? Do you want to commit yourself to memorizing only one of these? It's all depending on what you want to do. Well, cosine of 45 degrees is root 2 over 2. Sine of 45 degrees is root 2 over 2. Well, I have a fraction within the fraction, so let's multiply everything by 2. So we get 2 minus root 2 all over root 2. Well, we can have a radical within a radical, but we can't have a radical within the denominators. So let's multiply the top and the bottom by root 2. So what we end up having is 2 root 2 minus 2 over 2, which all those outside numbers are divisible by 2. So usually we like to put the -1 first and then plus the root 2. That's usually how you see that. We always like putting this kind of real number or rational number first and then plus that radical. So really there's no wrong way of writing it as long as you have the signs correct. Wait, this isn't one of those identities. Does this look a little familiar? It should. This is the double angle identity for sine. So 2 sine cosine or sine 32 cosine 32 condenses to sine of 2 times 32 degrees. So you end up getting sine of 64, which is not on the unit circle, so we can just stop there. What about this one? We have cosine of half of a degree, half of x over sine of half of x. Well, I could try to use these formulas here, or it's just cosine over sine. Cosine over sine is cotangent of whatever angle that they have, which in this case is 1/2 x. So the directions told us to write it in terms of a single function. There's the single function. All right, so what we're going to do is we're going to use our inverses that we talked about last unit and use the double angle identities that we've had in the past. So don't forget about your rainbow values. So tan inverse of -3/4. Okay, just looking at that. Again, inverse trig functions or arc trig functions are always asking for an angle. So this is going to give me an angle. And to kind of give it some familiarity with the double angle stuff, I'm going to just call it A. So tangent inverse of -3/4. -3/4 is not on the unit circle, but I can draw a triangle. So that's going to tell us that since we're dealing with tangent inverse, our rainbow values are the side rainbow. This is going to be angle A, and the opposite side is 3, and the adjacent side is 4. Be very careful with your negatives, because if we're going to the right, that's positive, but if we're going down, that's negative. And then if we do our triples, that's 5. So in other words, I can rewrite this as cosine of just 2a. Well, do you know what cosine of 2a is? Well, that's an identity. You have 3 choices to use. You could do, either one of the 3. And here, I'm just going to do cosine squared minus sine squared. So cosine here is 4/5. And I'm going to square that. Sine is -3/5, and square that. So we end up getting 16 over 25 minus 9 over 25, which gives us 7 over 25. So again, just using what we've done in the past with our new identities. Well, how can I use my 2 identities here, or my new ones here? Well, this gives me an angle. I'm just going to call this angle A. So if it's sine inverse and it's positive, then it's in quadrant 1. So this is angle A. The opposite side is 12. The adjacent side, or the hypotenuse, is 13. So the adjacent side is 5. Well, this gives me another brand new triangle. I'm going to call it not A, but B. And since it's cosine and it's positive, I'm just going to draw one in quadrant 1. And the adjacent side is 4. The hypotenuse is 5. So the opposite side is 3. So again, each inverse or arc gives me an angle, and I just called it something familiar so that whenever you see this, it's just sine of A plus B. Do I know an identity for a sum of 2 angles? Yes. It's SCSES. So sine of A, cosine B, same sign, cosine A sine B. So now we just look at our triangles, get sine of A is 12/13. Cosine of B is 4/5. Cosine of A is 5/13. And then sine of B is 3/5. So we multiply, get 48 over 65. We multiply those, get 15 over 65. No need to reduce because they're the same denominator. And you end up getting 63 over 65. Done. Again, make sure that you're making sense of this. Sine should never be bigger than 1, so make sure that that's always less than 1. All right, what about this last one here? Well, we have an arc, so this is going to give me an angle. And since we're talking about radians, I'm just going to call it angle x. So since we're talking about arc sine, and arc sine deals with a triangle in quadrant 4 here. So this is my angle x. The opposite side is 3, the hypotenuse is 5. And one of those has to be negative. The hypotenuse can never be negative, so that's going to be -3, and then this is 4. So in other words, arc sine of -3/5 gives me an angle x. I don't need to know exactly what that angle is. I just can assign it a variable. Wait a minute, that looks familiar. That looks like a cofunction. Secant and cosecant are cofunctions. If I have 90 minus an angle or pi over 2 minus an angle, I end up just getting the cofunction cosecant of x. So cosecant of x is the reciprocal of sine. Sine is -3/5, so cosecant would be 5 over -3. Doesn't matter where that negative is as long as the negative is there. So again, using the same triangles that we did in the past, just making sure you're using your rainbow values, drawing the triangles in the correct spot, and then finding our new identities. If you have any questions, make sure to bring them to class.